Alright, welcome back to Scholar Strive doing some math. Today we'll be working with polynomial division in Algebra 2. Alright, so what it looks like is we're dividing a function by a divisor, like 3 divided by 4, and then the quotient is our answer, and then we're going to have a remainder afterwards. Divided by the original divisor. So let's use a simple example to show. I'm going to take 40, or let's just use 40, and divide that by 3. So we have a function 40. We're dividing it by our divisor 3. So here's our let's use that divisor 3. And then we do it like normal. 3 goes into 40, or 3 goes into 1, or 3 goes into 4 one time. So we do that, and then we have a remainder of 1, go here. 3 goes here, and then we get 9 minus 1, or sorry, we got a positive 1. So we have a remainder of 1. So this is all the way back, kind of when we first started learning long division. 13 remainder 1, and what that means is that is 13 plus our remainder over 3. So this is our remainder, and then this is our divisor again, so the thing we divided by, and then this thing is our quotient. So let's work with something much more difficult. So there's two ways to divide: long division and synthetic division. First, we're going to do long divisions to see how that works. So for our first example, we have 2x to the 4th plus x cubed plus x minus 1 divided by x squared plus 2x minus 1. So what you want to do in long division is, well, create your little division symbol thing, got all that thing. And the thing that is being divided, also known as our dividend, 2x to the 4th is on the inside, plus x cubed. And then you want to make sure that you put in writing terms with 0 coefficient. So what that means is our x squared value is 0, right? So we're going to say plus 0x squared plus x minus 1. And then on the outside, we're dividing by x squared plus 2x minus 1. Okay? So now I'm going to ask myself, how many times does x squared here goes into 2x to the 4th? So I'm looking at my highest power. I'm trying to divide the first term by the divisor. So how many times does x squared go into 2x to the 4th? Well, we need 2x squareds. So another way to look at it, what do I have to multiply x squared by to get 2x to the 4th? I need to multiply it by 2x squared. Okay. Now, I need to multiply back Alright, I had to fix my notes there because these steps were written incorrectly. So just to review, I saw how number 2, divide the highest power by the first term by the divisor. So how many times does x squared go into 2x to the 4th? It goes in 2x squared times. Okay, now I'm going to take this 2x squared and multiply everything here. in parentheses, the divisor. Okay, so remember this is the divisor. Okay, so 2x squared times x squared is 2x to the fourth. And then we have 2x squared plus 2x, or 2x squared times 2x. Okay, so what I'm doing here is 2x squared times x squared plus 2x minus 1, and then I'm distributing it to all three of these. Okay, so 2x to the fourth, and then 2x squared times 2x is 4x squared. And then we have 2x squared times negative 1, which is negative 2x squared. Okay, and then our fourth step is to subtract. Okay, so those will cancel out. X cubed minus 4x cubed is minus 3x cubed minus 2x squared. Okay, and then our fifth step is to bring down the next term. So the next term here is plus x. Okay, and then step 6, repeat the process until our degree is higher than the degree in the dividend. So remember, the inside here is called the dividend. So here we go again. So I look back at my divisor, x squared plus 2x minus 1. How many times does x squared go into negative 3x cubed? Okay, so we have a negative 3 there, and then we just need an x to make that negative 3x cubed. Okay, now we're going to take negative 3x and multiply our divisor. So I have negative 3x cubed, and then negative 3x times 2x is negative 6x squared, and then negative 3x times negative 1 is a positive 3x. So we're going to subtract everything. Okay, so negative 3x cubed minus negative 3x cubed should be 0, and then 2x squared minus 6x squared is a positive 4x squared, and then we have x minus 3x, which is negative 2x. Okay, and then we drop our last number here, which is negative 1. Then we do it one more time. How many times does x squared go into 4x squared? Just 4 times. So we get 4x squared, and we multiply it back, plus 8x minus 4. So when we subtract that, we get negative 10x minus negative 1 minus 4 is plus 3. Okay, and then we're done. So this is our remainder. Only thing left to do is rewrite it up there. So we're going to plus our remainder, which is negative 10x plus 3, over our divisor, x squared plus 2x minus 1. Okay? And that is log division. All right, the second way we can do these division is called synthetic division. Now, we can only do this if we're dividing by a polynomial of degree 1. That means only x. So for example, x minus 2 here. So this is how synthetic division works. It's very similar to synthetic substitution. Take our divisor here, x minus 2, and set it equal to 0 to find out what your true divisor is. So x would equal positive 2. So this is going to be my divisor. Okay, and then we're going to create that little box thing again. So that's a 2 there. And then our numbers is going to be 2, -1, 4, and -10. Now, where I got those from is that these are the leading coefficients of our dividend, the thing that is being divided. Okay, so this is my my number in front of my x cubed, my number in front of my x squared, my number in front of x, and my number in front of my constant. Okay, or actually that's my constant, not the number in front of it, but it is the constant. Okay, and then just gotta do this here, and just like synthetic substitution, bring this down. I got 2. I'm gonna take these two numbers. 2 times 2 is 4. Okay, and then I'm going to add these. I can get -1 plus 4 is +3. Then I'm going to take this 3 and multiply by our divisor 2 to get 6. 4 plus 6 is 10. And then I get 20. -10 minus 20 is +10. Okay. So how do we translate this into an answer? Okay, our quotient. Okay, our quotient or answer is this. Okay. I look at these values here, the numbers that I have, and this is what it looks like. So I start off with 2x squared plus 3x plus 10 plus 10 over x minus 2. Okay, so the reason why I started with x squared is because this is going to be 1 degree lower than our original. So the degree we have originally is x cubed. So 1 degree lower would be x squared. So these new numbers that I created are the coefficients of our answer. And then the last one, our last number, is our remainder. Okay, so 2x cubed plus 3x plus 10 plus another 10 over x minus 2, because that's what we're originally dividing by, x minus 2. Okay, and then so the next part, use synthetic substitution to evaluate the polynomial in example 2. So what we just did at x equals 2. What do you notice? If you look at it closely, I did do x equals 2 for synthetic substitution. Our synthetic substitution, remember, is plugging 2 into our equation, and we actually get the remainder. So we would get 10 if we plug in x equals 2 into our original equation, or into our, not the original equation, into our dividend, the one that's being divided. We get 10, and that is the remainder. All right, let's move. So this comes to the remainder theorem. If a polynomial f of x is being divided by x minus k, then the remainder is always going to be equal to f of k. So what it's saying is, if you're dividing by 2, the remainder is going to be the same number as if you plugged 2 into the dividend. Okay, let's do another synthetic division example. Alright, 2x cubed plus 4x minus x minus 1 and x plus 3. So we're going to use the opposite of x, or positive 3, so we're going to be -3 here. And then we're going to look at our coefficients. So we have 2 for the x cubed value. We have 4 for the x squared value. We have negative 1 for the x value, and then negative 1 for our constant, or x to the 0. Okay, and then bring this down. Here we go. So bring the first number down. 2 times negative 3 is negative 6. 4 plus negative 6 is negative 2. Negative 2 times negative 3 is positive 6. Negative 1 plus 6 is 5. Negative 3 times 5 is negative 15, and we'll get negative 16 here. So my answer is going to be, so here is my new values. So this becomes my x squared, this becomes my x, this becomes my constant, and this becomes my remainder. I'll put a big R. There we go. So this becomes, our answer is 2x squared plus x. Oops. Sorry. It's reading the wrong line. So I have 2x squared minus 2x plus 5 minus 16 over x plus 3. So remember, x plus 3 was what we were originally dividing. Okay. Let's move on to the next example. Alright, for our next example, we have 4x cubed plus x squared minus 3x plus 7 divided by x minus 1. So remember, when we're dividing, when we're doing synthetic substitution, we're going to change that minus 1 into just x equals plus 1. And then we're going to write our coefficients. So our x cubed is 4, x squared is 1. Then we got minus 3 for our x, and then our constant is 7. Okay. Drop this down, and then we're going to multiply 4 times 1 is 4. 1 plus 4 is 5. 5 times 1 is 5. Negative 3 plus 5 is 2. 2 times 1 is 2. And 7 plus 2 is 9. So my answer is 4x squared plus 5x plus 2 plus 9 over x minus 1. Because that's what we're dividing by. Okay, remember, this is our remainder. So what if there is no remainder? If the remainder is 0, then the quotient is a polynomial and the divisor is a factor. Okay. So let's do some examples where the remainder is 0. Okay. So this is how it works. So example 5, factor this completely given that x minus 4 is a factor. Okay. So what you want to do is use synthetic division. Okay. So I'm going to use the opposite of x minus 4 is here. List out our coefficients again. 1 for my x cubed, minus 6 for my x squared, 5 for my x, and then 12 for my constant. Okay, and then we bring it down. I get 1. 4 times 1 is 4. Then we get negative 2. Negative 2 times 4 is negative 8. 5 plus negative 8 is negative 3. Then we get negative 12. See, our remainder is, in fact, 0. Okay, our quotient is right here, remember? And what's that going to look like? That's going to look like x squared, because that's one coefficient, and then minus 2x minus 3. Okay. So we want to completely factor it. So we remember that we know that this is now a factor, and then this was given to us as a factor. Okay. So all we do is take our x squared minus 2x minus 3 and factor it like normal. I'm going to have an x here. I'm going to have an x here. Oops. And we have an x minus 4 here. Oops. That's a 3. That's an x. Okay. So just looking at x squared minus 2x minus 3, what two numbers multiply to negative 3 and add up to negative 2? That would be x minus 3, x plus 1, and then we tack on our x minus 4. And now it is completely factored. So x cubed minus 6x squared plus 5x plus 12 factors into x minus 3 times x plus 1 times x minus 4. If you don't believe me, multiply it all out. Next example. X cubed minus 9x squared plus 8x plus 60. We're trying to factor it completely, given that x plus 2 is a factor. So I'm going to use negative 2 here in my synthetic division or substitution. This is division. So I have 1 for my x cubed, negative 9 for my x squared, 8 for my x, and then 60 for my constant. So, drop this down. 1 times negative 2 is negative 2. Negative 11 times negative 2 is positive 22. 30 times negative 2 is negative 60. And guess what? They're telling us the truth. It is a factor. Okay, my quotient is going to be x squared minus 11x plus 30. And they tell us that x plus 2 is a factor. Okay? So this breaks down into two numbers that multiply into positive 30 but make negative 11. That would be minus 6 and minus 5. And then tack on the x plus 2 there. That is now factored completely. Let's do one more example. So, when we're trying to find all the zeros of an equation, that's best to factor. Okay, so the example 7 is basically like example 6 and example 5, because they give us the fact that if I plug in that negative 2 is a factor, that it is a 0. So f of negative 2 is the same thing as saying x equals negative 2, or we're going to divide this by x plus 2. So I'm going to use negative 2 as the divisor here in our synthetic division, and then we have 1 for our x cubed, 2 for our x squared, negative 9, and then negative 18. Alright, here we go. Drop down the first number. So 1 times negative 2 is negative 2. 2 plus negative 2 is 0. 0. Negative 9. Negative 9 plus times negative 2 is positive 18. And of course we get 0 because they told us that it would work. So our quotient is x squared minus 9. Okay. And then we have x plus 2 here. Okay. So this x plus 2 is coming from here. If I move negative 2 over, I get x plus 2 equals, come on, there we go. Okay, one last step. Break this x squared minus 9 down. Now this is a typical a squared minus b squared. That becomes a plus b, a minus b, which is x minus 3, and then we have x plus 2 here. Is that our answer? No, because they didn't tell us to factor it completely. They told us to find the zeros. So I'm going to set this all equal to 0. I get x plus 3 equals 0, x minus 3 equals 0, and x plus 2 equals 0. So I have x equals negative 3, x equals positive 3, if it would let me, and then x equals -2. Alright. Hopefully there was enough practice in synthetic division. Now, I know if I scroll back up, long division will take some time getting used to. Make sure you practice. Alright. Have a good day.